Morning, ma'am. My name is D. Sacharan from 3rd Civil. Today, our topic is how wind and weather influence air pollution dispersion. This is our topic, how wind and weather influence air pollution dispersion. First of all, introduction to air pollution dispersion. Air pollution dispersion refers to the way pollutants spread from sources into the environment, and with wind and weather conditions play in circular role in determining the dispersion patterns. Understanding this influence helps in managing air quality and protecting public health. Here we can see the picture and the role of the wind in dispersion. Wind acts as primary driver that transport pollutants away from the sources. The speed and direction of wind affect how far and widely pollutants spread. Strong winds generally lead to quicker dilution of pollutants in the atmosphere. Dilution of pollutants. Wind helps spread air pollutants over a large area, reducing their concentration near the source. Direction of transport. Wind determines the path pollutants travel, influence which regions are affected by air pollution. Wind speed and pollution levels. High wind speed usually result in lower concentration levels of pollutants near the source. Conversely, low wind speeds can cause pollutants to accumulate locally, increasing health risks. Variations in wind speed throughout the day influence pollution dispersion patterns. Here we can see the picture, wind speed and pollution levels. Wind direction and pollution distribution. Wind direction determines the area most affected by pollutant transport. Changes in wind direction can cause pollution to shift from one region to another. Accurate wind direction data is essential for predicting pollution hotspots. Determining affected areas. Wind direction controls where pollutants move, deciding which regions of communities experience higher pollution levels. Concentration patterns. Transit's wind direction can cause pollutants to accumulate downwind, creating pollution hotspots in specific areas. Atmospheric stability and weather condition. Atmospheric stability refers to the tendency of air to resist vertical mixing. Stable atmospheric conditions trap pollutants near the ground, worsening air quality. Unstable conditions promote vertical dispersion, reducing pollutant concentrations at ground level. Here we can see the picture of course and compression. Temperature and its impact on dispersion. Temperature influence atmospheric stability and vertical mixing process. Warm daytime temperatures often enhance vertical dispersion of pollutants. Cold or temperature inverse conditions and trap pollutants close to the surface. High temperature cause air to rise and create low pressure areas due to decrease in air density. Temperature differences between regions influence the strength and movement of dispersion, affecting weather patterns like storms and rainfall. The effect of humidity and precipitation. Humidity and precipitation can remove pollutants from the air through wet dispersion. Rain can significantly reduce airborne pollutant concentrations by washing them out. High humidity levels may also influence chemical reaction among pollutants. Excess humidity can also promote chemical reaction in the atmosphere, leading to the formation of secondary pollutants like smoke. Complex interaction of weather factors. Multiple weather factors interact to influence overall pollution dispersion patterns. For example, wind speed combined with atmospheric sustainability determines pollution spread. These interactions complicate prediction models but are essential for accurate assessments. These interactions can either enhance or reduce pollution levels depending on local weather conditions and geographical features. Implications for air quality management. Understanding wind and weather influence helps in developing effective pollution control strategies. Weather forecasts can be used to anticipate pollution episodes and issue warnings. Urban planning and emission regulations can be optimized based on weather dependent dispersion patterns. Air quality management plans can be improved by adjusting emission controls and public advisories based on wind temperature and humidity conditions. Conclusion and future direction. Wind and weather are key determinants of how air pollution disperses in the environment. Advances in meteorological modeling improve prediction and management of air quality. Continued research is essential for managing pollution impacts under changing climate conditions. Weather factors such as wind, temperature, and humidity precipitation play a role in the dispersion and concentration of air pollutants. Effective air quality management requires understanding this interaction and predict pollution, reduce exposed risks, and implement targeted control measures. Thank you, ma'am, for giving me this opportunity.